Welcome to the project demonstration of permanent magnet synchronous generator to the DC load as well as inverting for the AC load. So here from this permanent magnet synchronous generator, so we are going to generate up to 48 volts, and it's going to be 50 watts of power can be generated from this dynamo. And after this generation, we are going to give the inputs to this battery through this charging circuitry. So here, coming to this battery, so we are using a 12 volt 4 amp battery. So here each battery pack consists of 4 volt 1 amp and is connected in series. So that 4 volt 1 amp is connected in series with the remaining 3 batteries. That's why we are getting 12 volt 1 amp, and these 4 battery packs are connected in parallel, and here we will get the 12 volts 4 amps. So that particular battery is going to be charged from this charging circuitry in 2 sources. So in 2 ways, like one is from the PMSG to this battery through this charging circuitry, and 230 volts input from this transformer. This is the secondary source to charge the battery for only demonstration purpose. In real time, don't require this. And from here we are making use of 4 diodes. The purpose of these 4 diodes are rectification purpose. So here, though we are generating DC power supply from this generator, why we are using this rectifier? Nothing but if is there any reverse direction rotation from this PMSG, then this particular rectifier will rectify that, and it will provide the pure DC voltage to this battery. And once the battery getting fully charged, there are the 2 different output purpose. One is a DC load from this DC bus, and another is IGBT inverter. We are making 2 on this AC load, right? So here just in order to utilize the AC load, just we switch on this, and then automatically the AC bulb, so though it is a LED bulb, but its input is going to be the 230 volts input. And so another is DC load from this one. So if you want to charge the battery from the PMSG, then connect the G at this T and G, and when we are rotating this particular generator, so actually it will be rotates with the help of wind, right? We can see the particular light is glowing here. So now I'm rotating in clockwise direction, so let us rotate in anti-clockwise, right? So there also we are going to generating the voltage, and it will be given as input to the battery circuit. So if you want to charge the battery to the transformer, just disconnect that and connect the transformer at the same slot and provide the 230 volts input here, and there we can see the green lights indication. So it will take minimum of 8 hours to 10 hours to be fully charged for this battery, and after that only we can utilize the particular voltage in the battery to the loads. So coming to this IGBT inverter, so we are going to generate the 50 Hz pulses of 12 volts, and that particular 12 volts pulses will be given as input to the IGBTs, MOSFETs. So after that, we are going to converting the 12 volts AC pulse to the 230 volts AC pulse. This transformation will be done with the step up transformer. So it will step up the 12 volts AC to the 230 volts of AC voltage. And here, from this controlling IC, we are going to convert the 12 volts DC to the 12 volts AC, and the MOSFET purpose is, so just in order to increase the current. So because the particular controller will not provide the maximum of current, so that's why we are making use of MOSFETs to increase the current, and after that only we'll get the high current, which input current of this batteries, which is of 12 volts of AC, and after that 12 volts of AC will be step up to the 230 volts of AC, and after that we are going to utilize a particular 230 volts at this load section. It's on and off for that, and this is the for DC bus load. So once again, through the PMSG's permanent magnet synchronous generator, right? So as it is in clockwise rotation, you can see that. Okay, you can see the LED indication on the charging circuit. So in this also, like any direction, we are going to getting the DC, which is sufficient to charge our 12 volt 4 amp battery. Thank you.